Hello, welcome back. We shall now discuss the third distribution in the category of special distributions. We have so far discussed chi-square distribution and F distribution. F distribution is a distribution of ratio of two chi-square distributions which are respectively divided by their degrees of freedoms. If x and y are independent chi-square variables with degrees of freedoms n1 and n2, then the random variable f, which is equal to x by n1 by y by n2, is said to follow f distribution with the n1 n2 degrees of freedoms. Okay, you see that here the random variable f is equal to x by n1 by y by n2. Numerator is the chi-square distribution with the n1 degrees of freedom, and denominator is the chi-square distribution with the n2 degrees of freedom. And you should write f distribution with the n1 n2 degrees of freedom. And you remember that this cannot be interchanged. The first degrees of freedom is the degrees of freedom of chi-square distribution in the numerator, and the second one, that is n2, is that of the chi-square distribution with n2 degrees of freedom. Now we shall see how chi-square f distribution is derived. Now you can see in the derivation you define two random variables u and v, which are functions of x and y. Okay, and you can utilize the method of transformation using Jacobian of transformation. And you see u is equal to x by n1 by y1 n2, and v is equal to y. And you can explicitly express x and y in terms of u and v, like x equal to n1 by n2 into uv and y is equal to v. Jacobian of this transformation is dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v, determinant, which is equal to n1 by n2 into v. And you know that v is always non-negative, therefore modulus of Jacobian is also equal to n1 by n2 into v. Okay, now you can write down the joint PDF of u and v as the product of, equal to the joint PDF of x and y, where the arguments x and y are in terms of u and v times the Jacobian of transformation modulus. Okay, so you know, since x and y are chi-square distributions, you know what are the PDF. The PDF of x is 1 by 2 to the power of n1 by 2 into gamma n1 by 2 into e to the power of minus 1 by 2 into x, then x to the power of n1 minus 1, and similarly that of y is also expressed in the same form. And here you multiply the PDF of x and y, and you put x and y in terms of u and v, and finally you will get this expression. You please verify whether this expression is correct. It will take a little effort. And the range of u and v are from 0 to infinity and from 0 to infinity respectively, because u is a ratio of x and y which are respectively divided by n1 and n2, and it cannot be non-negative. Similarly, v cannot be non-negative, and the range can be justifiable. And from this joint PDF of u and v, you can find the marginal PDF of u as fu of u equal to integration over v, the joint PDF of u and v with respect to v. So all the constant, you take all the constant from this expression outside the integration, and under the integration you can put the integrand like this, and this can be easily justifiable from this expression. Okay, and this integration is with respect to v, right? And you can see that this is a gamma integral which can be evaluated as gamma p divided by theta to the power of p, where p is equal to n1 plus n2 by 2, okay, and theta equal to 1 by 2 into n1 by n2 into u plus 1. Okay, then you can easily simplify, and all these things can be written in terms of beta of n1 by n2, n1 by 2, n2 by 2, and these terms can be written u to the power of n1 by 2 minus 1 because it is there, and you can see that this quantity 1 plus n1 by n2 into u to the power of n1 plus n2 by 2 in the denominator. Okay, and this 2 to the power of n1 plus n2 by 2 will be cancelled with this 1 by 2 to the power of n1 plus n1 plus n2 by 2, because this 2 to the power of this n1 plus n2 by 2 will be go to the numerator because it is in the denominator of the denominator. Okay, so that you can write this expression plainly in this way, where u varies from 0 to infinity, and this is the PDF of u, and this is the PDF of a f distribution. Okay, so here u follows a f distribution with degrees of freedom n1 and n2. Okay, so you can define a random variable capital X follow f distribution if its PDF is given by this quantity, where u and u can be replaced by x because we are dealing with the random variable x, and x takes the value from 0 to infinity. So you can easily obtain the PDF of f distribution. PDF ചോദിച്ചു കഴിഞ്ഞാൽ നിങ്ങൾ you have to define f distribution like this. Let x be a random variable whose PDF is this. ഇവിടെ വരുത്തേണ്ട മാറ്റം യുവിൻ്റെ സ്ഥാനത്ത് എക്സ് കൊടുക്കണമെന്ന് മാത്രം. ഓക്കെ, ആൻഡ് വാട്ട് ഈസ് ദി distribution of 1 by u? If you follow f distribution with n1 by n2, definitely 1 by u follows f distribution with n2 and n1. That is, you are just interchanging the degrees of freedom of f distribution. Why? What is u? U is equal to, okay, you can see that u is equal to x by n1 by y by n2. Okay, f is equal to x by n1 by y by n2. So what is the reciprocal of this f? 1 by f. 1 by f means y by n2 will go to the numerator and x by n2 will go to the denominator. Therefore that also will be an f distribution, but the degrees of freedom will be just interchanged as n2 and n1 respectively. Okay, so you always remember that reciprocal of an f distribution or an f random variable is again an f distribution. The only thing is that the degrees of freedoms are to be interchanged, so that once you know the probability associated with u, you can find the probability associated with 1 by u also. That is, I have explained here. 1 by u is taken as v, so that this u probability that u greater than or equal to c, that is equal to probability that okay, please make a correction here. Here it is not c, but it is 1 by c, because I'm taking on both sides in this bracket reciprocal. So when we take the reciprocal, this inequality will be reversed. So 1 by u is greater than or equal to 1 by c, not c. You please make it as another c or c dash, like that. You make the correction. And here we shall again discuss how the moments of f distributions are determined. That is mean, variance, and all other things you can find out of this moments of f distribution. What is mu r dash? Mu r dash equal to expectation of u to the power of r. That is integral from 0 to infinity u to the power of r into fu of u du, where fu is equal to the PDF of, is the PDF of f distribution. And you know what is the PDF? So this constant you can take outside, because it is in the, you see, it is in the, here, it is here. So all this constant you take outside, and you keep only this thing in the as the integrand, okay? So that you can take 0 to infinity u to the power of r into PDF without constant I have taken outside. And you can see that you can combine this u to the power of r and u to the power of n1 by 2 minus 1 together, so that this becomes, the numerator becomes u to the power of r plus n1 by 2 minus 1. Okay. And you can integrate this by putting y is equal to n1 by n2 into u. You take this for making this. Actually, you can put this into the form of a beta integral. That is what I am going to do. So for making that beta integral a very simple integral, you make the substitution y is equal to n1 by n2 into u, so that n2 by n1 dy equal to du. Okay. So, and u is of course n2 by n1 into y. You make this substitution in the integration, so that you will get this mu r dash, that is expectation of u to the power of r is equal to the constant which I have already taken out into integral 0 to infinity of this integrand which I have made by putting these substitutions. Okay. And finally you will put this is equal to this constant, and this n2 by n1 to the power of this quantity also you are taking outside, and here there is a term of n1 by n2, and you combine all these things, you will have this n1 by n2 to the power of n1 by n2 into n2 by n1 into r plus n1 by 2, because there is an n2 by n1. Okay. And finally you have this constant into integral 0 to infinity of this thing, and you can definitely see that this is nothing but a beta integral with alpha equal to r plus n1 by 2 and beta is equal to n2 by 2 minus r, because this quantity can be splitted into this r plus n1 by 2 and n2 by 2 minus r. Okay, you can see that this is justifiable. Okay, and this is the expression for mu r dash. Okay, so mu r dash is equal to this quantity. This is the quantity, and this is true for n2 greater than 2r. Why I am putting such a restriction? You see, this is of course a positive integer, and this is a positive integer only if this n2 greater than 2r. That is, you have to have this n2 by 2 minus r is greater than or equal to 0. That is, n2 by 2 is greater than or equal to r, and therefore n2 is greater than 2r. Okay, so you write this as mu r dash, and you can find some particular moments by putting r is equal to 1. You will get mu 1 dash equal to this, and on simplification you will see that it is equal to n2 divided by n2 minus 1. The simplification is very direct, and you may check whether this is true or not. And here I am I have to use a restriction that n2, it is not legible here because some part has missed in this PDF note, and you should restrict this n2 greater than 1. Why you are restricting n2 greater than 1? Because the denominator should not be a negative quantity and it should not be 0. So n2 should be greater than 1. That means if n2 is equal to 2, then you will have 2 minus 1. If n2 equal to 1, what will have? You will have 1 minus 1, 0, and this becomes indeterminate. That is why I am putting the restriction n2 greater than 1. Okay, so mu r dash, that is the first order moment, row moment, is equal to n2 divided by n2 minus 1. And what is this mu 1 dash? It is nothing but the mean of f distribution. Okay, so mean we have determined, and in order to find the variance, you have to find first mu 2 dash, and then variance is equal to mu 2 dash minus mu 1 dash. So variance also you can determine, and you see what is mu 2 dash. Mu 2 dash is equal to this quantity, because you put r is equal to 2 in this expression. So you will get on simplification, you will get this is the quantity, and you try to simplify this by expanding the beta functions in the numerator as well as in the denominator, and with a little patience you can see that mu 2 dash is equal to n2 square into n1 plus 2 divided by n1 into n2 minus 2 into n2 minus 4. And here also you have to make a restriction n2 greater than 4, because if else n2 minus 4 may be either 0 or negative. So in order to make this either positive, positive, you have to put n2 greater than 4. Okay, so you have found mu 2 dash, and here you have found mu 1 dash, so that you can find the variance. Variance is equal to, what is the variance? Variance is equal to this, which you can simplify as 2 into n2 square into n1 plus n2 minus 1 divided by n1 into n2 minus 2 square into n2 minus 4, with this restriction n2 greater than 4. Okay, and similarly you can find the mode of this f distribution. You try this, I leave this as an exercise. Mode is equal to n2 by n1 into n1 minus 2 divided by n2 plus 2, right? And you will see that this mode can be determined in such a way that mode is that value for which the PDF is maximum. Okay, the PDF is maximum. You know, the PDF of f distribution is this, and this PDF is maximum when the first order derivative of this integral is equal to 0, and you will have only one solution, and that solution is the value of mode. Okay, and I leave this as an exercise to you, and these are the main things regarding f distribution. Okay, and here so far we have discussed 3 special distributions: chi-square distribution, t distribution, and f distribution. ഇതിൻ്റെ പ്രധാനപ്പെട്ട ഉദ്ദേശം നമ്മളിങ്ങനെ 3 സ്പെഷ്യൽ ഡിസ്ട്രിബ്യൂഷനായിട്ട് പറയാനുള്ള കാരണം, ഇത് യഥാർത്ഥത്തിൽ ഈ ഡിസ്ട്രിബ്യൂഷൻസൊക്കെ നമ്മളെ സാമ്പിളിംഗ് ഡിസ്ട്രിബ്യൂഷനിൽ വരുന്നതാണ്. എന്താണ് സാമ്പിളിംഗ് ഡിസ്ട്രിബ്യൂഷൻ എന്നുള്ളത് വിശദമായിട്ട് ഞാൻ പിന്നീട് പറയാം. ഈ സാമ്പിളിംഗ് ഡിസ്ട്രിബ്യൂഷൻ, we are making samples, random samples from normal distribution, and using sampling from normal distribution we will encounter with these 3 distributions, that is chi-square distribution, t distribution, and f distribution. And of course normal distribution. And in the next video under sampling distribution, we shall see how chi-square distribution, t distribution and f distribution are derived out of simple random samples. Okay, and you please wait for those videos. Thank you.